this we will discuss motion, time and speed. Okay. So first of all, what is motion? When an object moves, we say that it is in motion. Remember the different types of motion we have discussed in the previous class? Linear motion, circular motion, oscillatory motion, periodic motion and random motion. Let's take a quick recap of these motions. The motions in which objects moves along a straight line is called linear motion. When objects keep moving along a circle, it is called circular motion. Back and forth motion, which keeps repeating, is called oscillatory motion. When an object that moves takes the some amount of time to complete one cycle of motion and keeps repeating it over and over, we call it periodic motion. When there is motion that follows none of these rules are random motion. So the soldiers of a march past. The soldiers keeps moving ahead in a straight line. So it is a motion called linear motion. Bullock cart moving on a straight road. The bullock cart keeps moving ahead in a straight line. This motion is called linear motion. Hands of an athlete in a race. The hands keep moving back and forth, swings back, swings up, again swings back. So this is an oscillatory motion. Paddle of a bicycle in a motion. The paddle keeps moving in a circle. So it is a circular motion. Motion of the earth around the sun. The earth keeps moving around the sun in a fixed orbit. This is circular motion. The motion also keeps repeating after a fixed period, 1 year. So this is periodic motion. Motion of a swing. The swings keep moving back and forth. So it is also a oscillatory motion. Motion of a pendulum. The pendulum keeps moving back and forth. You can see by the activity. Motion keeps or bob keeps of moving from its mean position to another position. So it is a oscillatory motion. When things move, they are said to be in a motion. How can we compare two things that are in motion? By how fast they are moving. We calculate the distance traveled in a certain amount of time. That is speed. Speed is the distance traveled in a certain amount of time. Let's write that as a formula. Speed is equal to distance upon time. The SI unit of distance is meter and the SI unit of time is second. So, the unit of speed is meter per second. If object A and B are going with the same distance, the B finishes faster. Which one has more speed? Of course, object B. And if object A and B are travel for the same time, but A covers more distance, which one has more speed? Very nice. It's object A. So we know that speed is equal to distance upon time. The SI unit we had already discussed, that is meter per second. And in the CGS unit of speed, centimeter per second. So how do we measure speed in a car? Kilometer per hour. When you are going from one place to another in a car, are you always at one speed? No. You have to slow down on turns, speed up when the road is clear, or you are overtaking another vehicle, is it? You may even have to change speed when you see obstacle like it's speed breakers or barricades on the road. Most of the time we are in a moving vehicle. The speed keeps changes. A bus has to do all that and keeps stopping and starting again at bus stops. What kind of motion is this then? When we are moving, but the speed of motion keeps changing. So we call this kind of motion non-uniform motion. When the speed of a motion does not change, we call it uniform motion. However, it is very unlikely that we would drive at one constant speed through the hour. For example, every time we overtake, the speed changes. Every time we stops. If the speed of an object keeps changing, it is called non-uniform motion. If the speed of an object is constant, it is called uniform motion. Let's look at the situations and say whether the motions are uniform or non-uniform. The school bus picking up children and coming to school. Yes, non-uniform motion. A car set on cruise control on an empty road. Uniform. A man running in a race. Non-uniform, maybe obstacles. An aircraft cruising at level height and steady speed. Uniform. Steady means constant. A horse running in a race. Non-uniform. Earth moving around the sun. Uniform. What is speed? New topic. Speed is the distance covered in a certain amount of time. So to calculate speed, we need to know the distance, we need to know the time, and we need to know the distance covered in 1 unit of time. By the formula, speed is equal to distance upon time. Now, when you go from Pune to Mumbai, let's say the distance is 120 km and it takes you 3 hours to get there. So what is its speed? Let's write what we know. Distance 120, time 3 hours, speed need to find out. How? Put the value in the formula. Speed is equal to distance upon time. So 120 upon 3 hours. So the answer will be 40 km per hour. So the speed is 40 km per hour. Now think, did you start your journey at 40 km per hour and stay at that speed constantly throughout? No, absolutely not. You must have had to speed up and slow down. You probably halted to get fuel for your vehicle and even for stomach, food. So, what is the speed that we have to calculate? It is the average speed. Average speed is what? It is total distance upon total time taken. We find average speed because in real life most motions are non-uniform. Let's have a quick recap what we have learned till now. The distance moved by an object in a unit time is called its speed. Speed of objects help us to decide which one is moving faster than other. The speed of an object is the distance traveled by the time taken to cover that distance. The basic unit of is meter per second. Now let's try some word problems, numericals. Before that, let's make one triangle which you can remember, and that will help you to do any problem based on speed, distance and time. Draw a triangle like this, and then draw a horizontal line in it and a vertical line below it like this. Then write the formula of speed like this. D at top, right side speed and left side time. That's it. Now, this is your weapon to attack any problem on speed, time and distance. Let me show how. Speed is equal to distance upon time, correct? So, S is equal to, you can see D is at top, T is at down. Distance is equal to speed into time. See the position, S and T are all together, so in multiplication. And time position, you just observe, D is at top, S is at down. Let's solve one numerical. A train travels at an average speed of 60 km per hour. It goes from station A to station B in 3 hours. What is the distance between the two stations? Speed is 60 km given and time is 3 hours. It is also given. Distance we need to find. What can be the formula? Distance is equal to speed into time. Is it? Check that the units are in the same system. In both cases, time is measured in hour, so it is okay. Distance is equal to 60 km and into 3 hours. So 60 km into 3 is equal to 180 km. Got? Next question. The distance between 2 points is 40 meter. An object takes 10 seconds to go from one point to other. What is the speed of the object? Distance is given, time is given, speed we need to find out. By the use of the same triangle, make a formula. Speed is equal to distance upon time. Fine. Check that the units are in the same system. Distance is in meter and time is in meter. Time is in second. So it is also okay. Let's put the value in the formula. Speed is equal to distance upon time, means 40 meter by 10 second, and we get the answer 4 meter per second. Next question. The distance between two cities is 120 km and a car is traveling between them at an average speed of 40 km per hour. How long it will take to cover the distance? Values of distance and speed is given. Time we need to find out. Again, check the formula. Time is equal to distance upon speed. Now I hope you can able to derive the formula of speed, time and distance of any question. Check that the units are in the same system. Distance is in kilometer and speed is in kilometer per hour. So this is okay. Time is equal to 120 kilometer and 40 kilometer per hour. So the answer, we get the time 3 hours. So if a car is going at a speed of 60 km per hour and it has to travel for 20 minutes. Now see here values are different. 1 hour here is 60 km and then it is 20 minutes. Let's find out the distance covered by the car. Derive the formula. D is equal to S into T. Before putting the value in the formula, we have to do the conversion. Check the units as I already told. Speed is in kilometer per hour and time is in minutes. So we have to convert speed to kilometer per minute. 60 kilometer in 1 hour means 60 kilometer in 60 minutes. Is it? Per hour we are saying it means 1 hour 60. So 60 into 1 upon 60. So speed is equal to 1 kilometer per minute. Distance is equal to 1 kilometer per minute into 20 minutes. So the answer is distance is 20 kilometer. Only we have to do the conversion. Let us practice some more questions over conversions. Convert a speed of 360 kilometer to meter per second. We know 1 kilometer is 1000 meter and 1 hour is equal to 60 minutes into 60 second means 3600 seconds. So 360 kilometer per hour is equal to 360 into 1000 meter upon 1 into 3600 second. Why we have taken 1? Because it is per hour, 1 hour. So the answer is 100 meter per second. Next question. Convert a speed of 6 meter per second to kilometer per hour. 1 kilometer is equal to 1000 meter. So 1 meter is equal to 1 by 1000 kilometer. Similarly, 1 hour is equal to 60 minutes into 60 second is equal to 3600 second. Already told. So 1 second is 1 by 3600 hour. So 6 meter per second. Here we have to convert bigger unit to smaller one. That's why we have done the division. 6 by 1000 kilometer and 1 per 36 kilometer hour. So the answer is 216 by 10 kilometer per hour or 21.6 kilometer per hour. Next we see a car moves with a speed of 40 kilometer per hour for 15 minutes and then with a speed of 60 kilometer for the next 15 minutes. Let's see, there are two intervals, is it? So we have to find the distance covered for each. First, time is given 15 minutes means 15 by 60 and speed is 40 kilometer. Distance first we have to find out, d1. And in the second interval, time is 15 minutes, same. So 15 by 60 converted into hour and speed is 60 kilometer, it is increased. Distance we need to find out. Formula, distance is equal to speed into time. So for the first half, 40 kilometer into 15 by 60 per 60 hour, that is 10 kilometer. And the value of d2 is 60 kilometer per hour into 15 by 60 hour, that is 15. So total distance covered is equal to distance 1 plus distance 2. So it is 10 plus 15 kilometer, that is 25 kilometer, means the total distance covered by the car is 25 kilometer. So here we had finished